Hello everyone, my name is Bhavak. I'm a senior security engineer at Certa Cybersecurity. In this video, I'm going to discuss about how to patch an iOS application in order to bypass some application-specific features such as jailbreak detection or SSL pinning. For this demo, I've already created an iOS application that detects if a device is jailbroken or not, and we will try to bypass this detection. So yeah, let's go and install this application. Just a second. So here it is, and as you can see, my device is jailbroken. I already have it installed. Let's install the application. I will be using FileZilla to upload the IPA file. Great. So the application is now installed. Let's open it. And as you can see, it already says that the device is jailbroken. That means it is already checking if the device is still on or not. And we will try to patch this thing. We will try to bypass this detection. And to bypass this detection, we will be using Hopper Disassembler. And what it will help us is to identify which piece of code is running to check this detection, and then we will patch it. So yeah, let's open this app in Hopper Disassembler. So here's the IDE file. Let's first unzip it. So we have a payload. So we will go to payload, and here it is. So the binary over here is jailbreak bypass, and this we will open it in the Hopper Disassembler. So for this demo, I will be using the free version of the app of the Hopper Disassembler, and it is sufficient. So let's try to open it. Great. So to give a brief overview of what is Hopper Disassembler is. So a Hopper Disassembler is a reverse engineering tool that is used to disassemble the binary into assembly language, and it is also a decompiler which converts this assembly code into a pseudocode. So what you are seeing over here is an assembly code, and if you want to see the pseudocode, it is similar to like this. Okay, so now we will go and see how we can patch it. So if we go to the app again and see, the status says over here is device is jailbroken. So let's search for this text where it is showing in the application. So here it is, device is jailbroken. So this is a piece of code, and we will see who is calling this code. So references to this code, and here we are. So this is the assembly code which is being called to check, which is being called right now. And when we move to this CFG mode, it shows how the flow of the code is happening. So we can see over here is this is being called device is jailbroken, and if we just like this. Now if you see, there's another code that is running, device is not jailbroken, and this is what we want, right? And what is happening over here is so before patching anything, let's first try to have a developer perspective. So what developer might have done in order to test if a device is jailbroken or not. So there can be a piece of conditional statement that is checking if a device is jailbroken or not. There might be an if and else statement that is doing a comparison, and that's what we have to modify. So if the if statement is calling this piece of code, and if the else part of the code is calling this statement, we have to interchange it, and that will be sufficient, right? So if we see the flow of the application, and you can also see the pseudocode of it, this thing, and also the hex representation of it. So this is the pseudocode, and this is the flow. So if we just go above and see from where this code is being called, this is device not jailbroken, and this is device is jailbroken. Just if we go above, we can see over here is this block is calling these two branches. First for the jailbreak, which is device is jailbroken, and the other one is for the non-jailbroken. And this is where we have to interchange things. And this piece of code is doing this. So what is TBNZ? So let's search what is TBNZ. Let's see what it says. TBZ and TBNZ. Test bit and branch if non-zero. So what is happening over here is it is calling TBNZ, and if you see the location it is pointing to, it is pointing to this thing, and this one are same, right? So if it's true, then it is being called, and this is what is happening right now, and we want to interchange this. And what we can do over here is we can change this instruction, that is TBNZ, to TBZ, right? So, and that's what we are going to do over here. So we will convert this TBNZ to TBZ, and how we will do it is like this. So let's first see from which address this is being called from. So let's copy this address and paste it over here. Right to white. Plain. Okay, this is the address, and the instruction that is called over here is, this is the hex representation of this instruction, which is TBNZ, right? So let's, and we're going to convert it into TBZ. So let's search for TBZ instructions in the app. TBZ. So first is this. Let's make a copy. Let's again do some and send off. Also, let's do it for TBNZ. So it's enough. So if we see a comparison between TBZ and TBNZ, we can see only the last one is changed from 6 to 7, right? And everything is same. So the instruction that we need to change over here will point to 40000036, which will be TBZ. Okay, and this is what we are gonna do it. Since the free version of the Hopper Disassembler doesn't allow patching applications, so we will be using terminal for it. So let's open terminal and let's do it. So let's open this binary in Vim. and we will be using, and we will convert it into a hex, so it's readable and we can modify it. So we will be using XXD. Since cool. So as we can see, it's a hex term over here, and we will patch it. So let's first find this address where it is. Also, if you can see, we won't be able to get directly to this pattern. So what we have to do is, let's go to the nearest one. So let's go to this, and here we are. See, and the instruction, it's pointing to the 0003637, and as you can see over here, it's pointing to 4000037, and we have to convert this to 36, right? So let's convert it. And that's it. Let's convert it into again binary xxd-r, and let's save it. Great. So it's done. Let's convert this into, let's zip it and convert it to IP again. So what we will do is app.zip payload. So we have app.zip, and we will convert this app.zip to app.ipl. Cool. So let's now install this app.ipl, and it should work. So we first delete this. And let's install it again. This is the app.ipl. So let's install it. Cool. So it's now installed. Let's open it. See, the device status is now changed to devices not jailbroken, and hence we have bypassed the jailbreak detection. So yeah, this is how it's done, and hope you guys like this video. And if you have any questions regarding it, just ping me on Twitter. My Twitter username is bhavukjain1. I would be more than happy to answer any questions if you guys have any. And yeah, that's it for now. See you in next video. Cheers.